Another important distinction is linear versus nonlinear ordinary differential equations. And it's really that linear differential equations are difficult to solve, and nonlinear differential equations are really, really difficult to solve. So actually a lot of methods you use only work for linear differential equations. So a linear ODE has this form. So you have p sub n for some nth function here. We have to name them with subscripts. It's a function of x, not as it doesn't have any y's in it, and that's paired with y at the nth derivative. Then you can have plus another function, this one's sub p sub n minus 1 of x, and that's paired with y to the n minus 1th derivative. And then plus 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 dot dot dot. You have p1 of x, which is paired with y prime, plus p sub 0 of x, which is paired with y, equals g of x. So these p functions can be absolutely horrendous, monstrous, complicated. That doesn't matter. The only thing that matters is that nothing is really going on with the y terms. They're just multiplying some x's, and they're not multiplying each other. They're not 1 over y. They're not sine of y. They're not e to the y. They're not multiplying each other. That's all that you need. And so the other thing is, if an ODE is not linear, then it is nonlinear. So pretty much everything that doesn't fit this format is a nonlinear ordinary differential equation. So here are some examples. So y double prime plus y equals 0. So in this one, the function in front is just 1. The function in front of y prime is 0, and the function in front of y is 1 equals 1. That's a linear ordinary differential equation. This other one here, we have tangent of the natural log of x over x squared plus 1, that whole thing, times y double prime plus x to the power x times y equals e to the sine of x. That one is linear, right? So these functions of x multiplying the derivatives of y can be absolutely monstrous. This one looks really bad, x to the x looks really bad, e to the sine of x looks really bad, but it's just y double prime times a monstrous x function. It's y times a monstrous x function, and then it's equal to a monstrous x function. So that is linear. Versus all of these other ones, right, we have y prime squared, so y prime times y prime plus y equals 7. Because of that y prime squared, this is a nonlinear ordinary differential equation. In this one, we have y double prime times y prime. It doesn't matter what else is going on in the equation, just that first term makes this ordinary differential equation a nonlinear ODE. Here we have y, the fifth derivative, plus 1 over y equals e to the x. That 1 over y term makes the entire ODE nonlinear. Here we have y double prime plus sine of y prime plus y equals 1 over x. That sine of y prime is a nonlinear term, so the entire ordinary differential equation is nonlinear. Here we have y double prime plus e to the y equals 4. That e to the y, that makes the ODE nonlinear. Natural log of y prime plus y equals 0. That natural log of y prime is going to make that ODE nonlinear.